everyone, today we are going to learn about Spring Boot Transaction Management, a feature that ensures your application processes tasks reliably and consistently, even when something goes wrong. Let's imagine you are shopping online and you place an order, and the system deducts the stocks, charges your credit card, and send you a confirmation email. These things are basically happened whenever we are doing something like shopping online or maybe any other shop, and whenever you are going to place an order from the some e-commerce site. So these are the like basic thing that we are doing in a day-to-day activities. Now let's think about it. While doing this kind of activities, something is going wrong. Something fails in the midway of doing this kind of transaction. For example, let's say your credit card is getting charged but stock was not updated. Vice versa, sometimes your card is charged twice because of a system error, right? So this kind of situation we may face sometimes in our real scenarios. So this is where transaction management comes to the rescue. It ensures that all related tasks succeed together or none at all. So that's why this is very important topic, that how we are going to manage the transaction in our application whenever we are going to doing this kind of application like in a project. Then we need to think about how we are going to manage this transaction, because this is very crucial part of our application. So that's why this is we need to handle into our application, and throughout this session I'm going to talk about this with different types of features of it, different types of properties. So keep with us. So next, actually I'm going to talk about that why transaction matters. So if we talked about, like, let's say you are transferring money between two banks accounts, from let's say account A is debited and the account B is credited, right? If something goes wrong between these two steps, like a network failure or an unexpected error, your application must ensure that both operations succeeded or none at all. This is called atomicity, a key property of transaction, right? Like in a transaction, basically whenever we are going to implement, it's actually follow the ACID principle to ensure atomicity, consistency, isolation, and the durability, right? So that I have pointed all the points over here. Now, without proper transaction management, what happened? Your system may end up with partial data updates causing inconsistencies. User trust in your application might erode due to data corruption. Spring Boot simplifies the complexities of transaction management through its powerful @transaction annotation, right? So the purpose of this transaction are very essentials for ensuring data integrity and consistency, especially in system with critical operations like banking, e-commerce, all this kind of project. We need to maintain the transaction. Without transaction, partial operation can corrupt data. Example like money deducted from one account but one account is not credited. So that means there is a data corrupt, right? So means if there is a chances of loss of data, so it will cause lots of issues. So that's why transaction is very important to maintain into our application. As I said, transaction implement ACID principle. Atomicity means all operation either complete or none at all. Consistency means database moves from one valid state to the another, and the isolation is the concurrent transaction don't interfere with each other. And the durability means changes persist even during system failure. Now we will talk about the types of transaction. Means like how many types of transaction in a Spring we is available actually. So in a Spring, basically Spring Boot provides seamless integration with transaction management, abstracting away the boilerplate code. So it uses the Spring Transactional API, which supports first one is the declarative transaction management, another one programmatic transaction management. In a declarative transaction management, we just need to use annotation like @transaction, right? In programmatic transaction management, it's actually using the transaction template or platform transaction manager. The most popular approach is declarative transaction management, as it is simple, readable, and requires minimal configuration to apply into our program. So these are the types of transaction. One is the declarative, another is the programmatic. Based on our need, we can use this type of transaction into our application to make the system more reliable. Next, we will talk about the detail more of it, like this declarative transaction. So let's talk about the declarative transaction. So here we need to understand that how these things actually work. Declarative transaction management is an approach to handling transaction in application where the transaction behavior is specified declaratively, typically through configuration or annotation, rather than the programmatically in code. So that means it is actually maintained by the programmatically, not programmatically. Actually, there are some annotation that we need to apply into our program. This simplifies transaction management and reduces boilerplate code, making it easier to maintain. In Spring Framework, declarative transaction management is basically achieved using @transaction annotation. This allows you to define transactional behavior like propagation, then isolation level, rollback rules. So there are certain things that we need to apply. I will come into that later part. But these are the things that we need to apply directly on the class or methods without writing explicitly transaction management logic. So that means this is very easy. We just need to apply on the method level or the class level, like this transaction annotation. As you can see, it's basically managed using the transactional. Then what it will do, basically it will like it basically simplifies the transaction management by delegating boundaries to the Spring, right? So the use case of this one, like when basically we are going to use. So the use of this one, it's basically standard use cases where Spring can automatically handle transaction commit or rollback. If we talked about, like, this is basically annotation based, we just need to annotate your service or method with @transactional annotation, and Spring automatically manage the transaction lifecycle. Transaction lifecycle means begin, commit, or rollback. Okay. Basically, Spring uses the AOP proxies to wrap the annotated methods and apply the transactional behavior when the method is executed. What is the advantage of it? Like, if we talked about like what is the advantage of declarative transaction, the advantage is it's actually reduce the boilerplate code. Means we don't need to write manually start, commit, or rollback logic into our code, right? It automatically maintain once we annotate particular class or method @transactional. It's improved the readability, like transaction behavior is declared alongside the business logic, making it easier to understand. Flexibility, if we talked about the flexibility, you can define specific transaction properties like propagation, then isolation, using attribute of the transactional annotation. If we talked about the consistency, so centralized configuration ensure consistent transaction handling, right? Now if we talked about some kind of the example, so if you see, if this is the method, then we have annotated this particular method with @transactional. So this transactional ensures a transaction begin when this process order method start. If any exception basically occur in between, all changes are rollback. If the methods complete successfully, the transaction is basically committed after that. So if we talked about the key attribute, so it's actually taking some attributes like propagation, isolation, then rollback for, no rollback for. So some annotation they can use. So I will cover those things in later part of this presentation. Okay. Now when basically we are going to use this one, right? So declarative transaction management is ideal when you want to a clean and simple way to handle the transaction. In this time we are going to use this declarative transaction. Next, like if we talked about the consistency in applying transaction behavior across your application, then also we can use this declarative transaction. If we want to reduce the complexities and code maintenance, then obviously the declarative transaction is the more preferable. It is widely used in application built with Spring Framework due to its simplicity and power. Next, we will talk about the another type of transaction, that is programmatic transaction management. So now we will talk about this one, that how basically it will work. This programmatic transaction management is a way of managing transaction in an application by explicitly coding the transaction boundaries, like when to start the transaction, when to commit the transaction or roll back a transaction. Means we need to explicitly control using the platform transaction manager. Unlike declarative transaction management, which uses the annotation or maybe XML configuration, programmatic transaction management provides more fine-grained control but requires more boilerplate code. In Spring, programmatic transaction management is implemented using the transaction template class or the platform transaction manager interface. Now if we talked about that when basically we are going to use this one, when you need fine grained control over the transaction boundaries, right? For certain scenarios, when the transaction behavior is dynamic or conditional, then obviously we don't have control on the transactional annotation, then maybe we can go with this programmatic transaction management. When manual invention is required to control the commit or rollback based on a specific condition within the method. However, if it is very less commonly used in most applications, since declarative transaction management is simpler and sufficient for typical use cases. So as I said that Spring provides two main ways to implement this programmatic transaction. First one is the transaction template and another one is the platform transaction manager, right? So as I said, the use case of this one, let me go back over here. So it's a basically non-standard cases where transaction need partial commit or multiple boundaries, right? So here basically if we check the like examples of it is like here basically we can defining the like start the transaction over here, and after that like we can create this one using this transaction manager dot get transaction with this default transaction definition. Then we whatever the database operation we need to perform, that we can perform over here, and after that we can do the commit over here. In case of any exception is occur, then we need to manually write the rollback logic over here under the exception. That can also write in somewhere else. Each base depends on the like business logic. What is the advantage of it is like it's a fine grained control, like it's allow dynamic transaction boundaries based on runtime conditions. It's also custom rollback rules, like we can decide when and how to roll back manually, right? Because that is on our hand, when and how to roll back the things. And also flexibility. It's suitable for scenarios when declarative transaction might not fit. In certain scenarios where we are not able to apply the declarative transaction, in that particular scenario we can apply this programmatic transaction. If we talked about the disadvantages, so obviously we need to write the more boilerplate code, right? It's also improve the complexities, and maybe certain scenarios that maybe error maybe come because we are handling transaction manually. So these are the disadvantages of it is. So while this programmatic transaction management provide greater flexibility, it is generally used only in advanced cases where declarative management cannot meet a specific needs. For most application we have used Declarative transaction management with @transactional is recommended as it is easier to use. It's like less error prone and sufficient for most scenarios. Okay. Next we will talk about the different types of propagation type. Okay. So that actually we'll talked about, like previously you have seen that propagation actually we have used within the transactional annotation. So over there are different types of the propagation. So what are those types? Okay. So we will now talk about this one. Okay. So this are the basically now we will talk about the transaction properties. So if you see, one of these properties is the propagation, then no rollback for, then isolation, then transaction manager, then read only, then timeout, and rollback for. So these are the basically properties that basically we have used. Now we'll talk about that what are the different types of propagation type, right? So this is one type of transaction. So here if you see, that is one is the required means it's actually join the current transaction, or it will create the new transaction if none is exist, means there is a one transaction maybe is going on. If we define the propagation type is required within the transaction annotation, then it will join the current transaction if any, or create a new one if none is exist. This is the default behavior of the propagation type. Okay. Next we'll talk about the never means it must run on the non-transactionally. It will throws an exception if any transaction is exist. Then we'll talk about the require new. It's actually suspend the existing transaction and creates a new one. The nested means obviously as name suggests, the nested is the creates a nested transaction that can be rolled back independently of the parent transaction. Supports, it's actually join the current transaction if it is exist, otherwise execute non-transactionally. And the not supported means it's execute the non-transactionally and suspending the existing transaction. And the mandatory means must run within an existing transaction, throws an exception if none is exist. So these are the different types of propagation type. So that are mostly we are using while we are doing the transaction, declarative transaction, then we are going to use as a parameter of the propagation. So these are the 7 parameters that we are basically used within the propagation. Next we will see the different types of the isolation type. So these are the 5 isolation types: default, read uncommitted, read committed, repeatable read, and the serializable. Like here also you can say like this default means like it's actually uses the database default isolation level. The read uncommitted means it's actually allow the dirty reads. Okay. Data changes by uncommitted transaction are also visible. So this is the means actually. Dirty reads means suppose the one transaction is going on but transaction is still is uncommitted mode. So those data also visible for this read uncommitted. Read committed means it's actually prevent the dirty reads, only committed data is visible, right? So this is actually the means it will give us the proper data. Repeatable read means it's actually prevents dirty reads and non-repeatable reads. It's ensure consistent data during a transaction, right? And serializable means it's a fully locked data for transaction. It's prevent the dirty reads and non-repeatable reads and the phantom reads. So these are the types of this propagation as well as the isolation type. Hope this is clear to you all. If you guys have anything, please do comment me in the comment section. Next we will talk about that read only. This is the another type, transaction type, the read only. Okay. So if we talked about that how it is work, this read only property optimize the performance by preventing data modification in the transaction. Let's say so there is a one property basically that we are using in a transaction. Suppose we are going to fetch some records from the database. So on the time we are going to use this read only property in a transaction, right? So it will improve the performance. Okay. So use case of this one, like while we are going to fetching some data from the database. If we talked about some examples, like if you see that within the transactional annotation we have used that read only equals to true, right? So this is where actually we are going to use this read only properties over here. Like we are going to fetch some records from the database and then it's basically used. So it will basically improve the performance by preventing data modification in the system. Next, similar kind of another property, that is timeout. So this is another good property or important things that we need to understand, that where we are going to use this one. The timeout property specifies the maximum time a transaction can run before timeout or rolling back. Let's say we are going to calling some payment gateway integration we are having. Now if we are not going to timeout, that may be lock our resources, and so that it will maybe taking more time, so we are not doing some other activities. It may be causing the locking issues. So that's why this timeout is more important. Why it is important? Because if such scenarios, maybe we are not able to reach out to them, or maybe there are some network issues or something, then after certain time, whatever the timeout we are going to define over here, after certain time it will give us the timeout. That can be dynamic timeout, like in second, 30 second or 10 second or 50 second, that you can define. So till then it is not able to, like we are not able to get some responses, then it will do the rollback or maybe do some activities or give us some message. So it will not lock the system from our end. So this is the benefit of this one, timeout. Next we are having the rollback for. So sometimes what happens, like we need to use some this rollback property. It's for some exception we need to specify it that we need to do the rollback. So here that this property actually doing these activities, like if we know that for this particular exception we need to roll back the whole transaction, so we need to use this property under this over here. So if you see in this way, basically we can use this one, like at the transactional over here, rollback for this is property equals to that exception we need to define over here. So that means once it will receive this particular exception, then it will do the rollback. Vice versa, another property we are having, which is the no rollback for, means it will, suppose in some certain scenario if we are going to receiving this exception, then it will not going to roll back the like transaction. So it's a graceful exception handling, means we are avoiding particular exception. So for this particular exception, it will not going to roll back the data. In this way, basically we can use this property like no rollback for equals to a specific exception dot class. So this is a customized exception. If this particular exception it will get, then it will not going to roll back the complete transaction. Okay. Next, another things we are having, that transaction manager. So what is it? Like this is basically specifies a specific transaction manager to use when multiple transaction managers are configured. So there basically we are going to use this custom transaction manager if we are having multiple transaction manager in our system. Then in this way basically we are going to use, so the transaction manager, this is another property that we can use with this transactional annotation, and here we are going to defining the name for it. So this is actually all for this one. Okay, so now we will talk about the best practices, like what we need to follow. As I said previously also, that use read only for the queries where we are going to fetching the data, so that it will unnecessary not going to modifying the records. Next one is the appropriate timeout value, like if you are going to integrate with some other third-party APIs or something over there, based on certain situation we are going to doing the rollback or something. So obviously we need to set the timeout values so that it will not going to wait period is the more longer than expected, so that we can get the better performance over there. Next one, carefully choose the propagation and the isolation type, right? Else it will causing lot of issues into our transaction management. and also like handle the exception wisely so that it will improve the system better. And the last one is, obviously once we have applied all the things, obviously we need to monitor the performance of the system so that if anything is occurs, then we need to optimize the system so that no one can face the logging or some kind of slowness issues into our system, right? So this is actually about this tutorial. So you have successfully like completed this tutorial on Spring Boot transaction management, and I hope obviously you now feel confident in managing transaction effectively in your application. Throughout this session, we explored the importance of transaction in ensuring data consistency and integrity, especially in complex systems. We discussed transaction properties like propagation, isolation level, timeout, rollback properties, and also some other things, right? Which give you more precise control over how your transaction behave. We also compare the ease of declarative transaction management with the flexibility of programmatic transaction management, equipment you with the right tools for different scenarios. The knowledge you have gained here is essential for building resilient, scalable, and fault-tolerant application. Always aim to follow best practices like use the declarative transaction for simplicity and maintainability. Optimize isolation level for performance in multi-user environment. Handle rollback rules carefully to avoid data inconsistencies. As you implement this concept in real-world project, remember that every application is unique. Thank you for joining me today in this tutorial. Keep exploring, building, and refining your expertise with Spring Boot. See you in the next session and happy coding.